Welcome back, dear friends. Great to see you again, sort of. Now today, we've got some shell lamps to make and some sound effects to wire up. How exciting! There's the Dinosaur time machine, still sitting here. Been discussing with Ben what sound effects he wants, how he wants it to operate, basically, as a time machine. And here is a wonderful, well, I hope it is, because I haven't actually tried it yet. Looks like it's a wonderful sound effects unit module. And what I particularly like about this module is I can actually see components. And I can look at the board, the circuit board, and work out things like, there are the memory chips. There's little rows of pull-up resistors there. There's the management chip that controls everything. There's the analog to digital and digital to analog, try saying that fast, chip. And there's the amplifier, and there's the audio bits. It's an absolute joy, oh, screw terminals. Oh. Now the great thing about this, I've already gone off at a tangent, the great thing about this board, I hope, is that it's got a maximum of 8 minutes of audio recording in mono. And using these dip switches here, you can adjust whether that is one message with 8 minutes long, right down to 32 messages of 15 seconds, I think it is. But I'm going to use 16 messages of 30 seconds. So that gives you so much variety. It's lovely. And you just ground any of these terminals and it will just play that particular sound effect. Because I want to have this as it rotates. I'm reading out as the child in the school, because this is, remember, if you've watched the last video, this is for Jurassic Jabber, who goes into schools and inspires young children with a fascination for paleontology, dinosaurs, fossils and the such like. So as they turn this, I'm telling you what I'm going to do, and I haven't even done it yet. Oh look, sliding things. So anyway, we're going to get on with that, but not yet, because first I've had an order for 8. Yes, that's 8. Very exciting. Of the miniature shell footlights. They're not this size, which is the biggest one I do. They're not that size, the 20mm high one with a miniature little LED in it. They're the middle ones, sort of, the 25mm, so that's an inch high. So as you can hear in the background, the 3D printer, because I make these to order basically, I've managed to print 2 of them so far. I had one ready made up, and they're lovely, aren't they? Beautiful. So what I'm doing now, I'm sitting watching some telly, and I've made up 8 of these little circuits with the warm white miniature LED at the top. And now I thought this is what prompted me to start this beautiful jig, even though I say so myself. Let me get the tripod. Now I regularly have to cut up lots and lots of bits of similarly lengthed wire, and this is why this is so useful. You poke the end there, you hold it like so. I want 8, so 1, 2,
3, 4, 5, 6, 7,
8. And then, you cut them off, and it leaves you with 8 pieces of wire, all the correct length. It's such a boon. I used to use a bit of wood with a nail at each end, wrapping it backwards and forwards, but basically you'd end up with bends at the end. Look! 8 identical little LED circuits. Now several people in the past have suggested or asked, why don't I just get some PCBs made up and with the components already put on them. Thing is, I don't really break even with these shell lamps, because they take so long to 3D print, and then I have to clean up each one, and I have to do that and then this and I can't charge that much for them. It's one of those typical products that I come up with on a regular basis that isn't viably possible, or whatever the word is. The thing is that there's nothing else like this on the marketplace, and if you've got a little model Victorian theatre, or indeed a steampunk machine, which is what prompted me to make these, they're invaluable. So I'm just I'm doing it as best as I can, as cheaply as I can. So, stop littering. Now, another top tip for you. I want to glue these into there, well, one of them anyway. I could use araldite or something, but I found the best way to do it is to use hot melt glue, but not just any hot melt glue. If you use the grown-up version of hot melt glue, it's so hot that obviously it's as hot as, or hotter than, the temperature that PLA filament melts. So you ending up with a strange mess. But the answer is to use one of these, which is a low temperature hot melt glue gun for younger children and things, and also older children, because having used some normal glue guns in secondary school years, they were warned, needless to say. So this is brilliant because it melts at a much lower temperature, but it's perfect therefore for this sort of thing because it doesn't damage the outside, and this has got quite a thin thickness, wall thickness. So I'm going to put one lot in just to fill up the gap, and then another little squidge, and glue each of these in. Oh, thank you very much. And voila, as we say in the miniature shell lamp making trade. Lovely. I'll leave them on for a little while just to make sure they will work perfectly. Another day, and it's magnet time. I can get on with this. I can't wait. And that. Oh. So I've got all that apart. What I need to do is to arrange 16 reed switches around here with a little magnet. I've got a reed switch connected to my multimeter there, so you can see what I am talking about. There it is. If I bring a magnet, I've got two magnets here. I'm probably going to use this flat one, but if it comes into proximity, quite some distance as well really when you think about it. Or there's this very strong neodymium magnet that it can be that distance. It's amazing. Reed switches are brilliant things because they're two pieces of metal in a sealed tube filled with some inert gas, and they just go on forever. In fact, about 15 years ago I bought my mum a wireless weather station that had an anemometer on the top of it, and about 5 years ago it stopped going round, so I took it to pieces and found that the bearing at the top had seized up, bit of oil on that to free it up, perfect, and I was amazed to find that it had a reed switch inside and a little offset magnet on the bottom of the spindle. So as the three cups span round, every time, every rotation, it would send a pulse. And I just assumed it would be a Hall effect, a solid state Hall effect sensor. But it wasn't, and this little reed switch, which was still working perfectly, must have spun millions and millions of times round in 10 years, with the wind spinning it, so they really do last a long time. Anyway, stop ranting about that. I'm going to try and sort out how to position and move these magnets and things. I should add how they work. If you hold it flat, with north and south going across it, nothing happens. But if you hold it this way, what happens is the magnetic force lines magnetise one of these strips of metal and the other one, so it's north and south, and then they attract each other together. It's ever so clever. So what I'm doing now, other than creating moire patterns, is I'm making a template so I can work out where each of the reed switches is going to go. And I've decided, after much umming and ahhing, that I'm going to use 5mm thick acrylic on the inside to support the magnet in there. So that worked nicely. There's the template. And then use the centre punch just to mark through, so I now know exactly where the reed switches are. I've also cut out the thing, which I've now lost. Here we are. So this is what it's going to look like. It will fit on there, and then that should... It's interesting. Got the measurements wrong. Never mind, I can glue a little bit of felt or something in the end here, which will be good as a stop. But you can see there's where the magnet's going to go. So now what I'm going to do is to machine this and put a couple of grub screws, taps for grub screws, get the magnet glued in, and start working out how to cut up this Veraboard. I don't want to blunt my bandsaw blade, even though it's copper. Well, it's copper, which I know is soft, but it's also fiberglass, so that's not going to be good for my bandsaw blade. I'm going to have a think about that. I've found a solution. There's a little bench saw, a minute one, that I set up for my wife when she's making her steampunk doll's house thing. So that's nice, and there's a hole in the back for a nice hoover to get all the dust, and it does work, sort of. But so I'll try and guide it a bit better, but that's alright because I can sand that. And thanks to many of you, I should mention this, who suggested using an Arduino and an MP3 player and things, which I did use for the ukulele playing machine and the singing automaton, but it took me ages to work out and to wire it all up and everything else. And I just thought, err on the side of caution with this project, because I need to get it done. I just use a sound effects module and switches and things, just to make sure. It would have been fun, but it's just weighing up the cost of my time against the cost of just buying something and putting some wires on. So I ended up doing it this way, and I'm always interested in trying new devices and things, so we'll see how it goes. Here's a little top tip for you. You've got to be very careful when not to put any force on the wires, because they're just going into that little glass sleeve. I found the perfect way to fold them, especially when I'm looking in the wrong place, is to use a pair of side cutters. If you use pliers you can't get close enough, but side cutters, as long as you don't squeeze too hard, you can then bend the wire over, and that's really close. It's closer actually than you can get with even small pliers. Thank you very much. And now what I'm doing, having bent the legs over, I'm soldering them into bits of error board. I'm then going to trim the legs down on the back and then just sand it flat, because then I can glue this down. I was thinking I could make holes and put bits of wire around, or screw heads or something or other, straight into the wood, but because these are so fragile and the wood expands and contracts even by a minute amount depending on the weather and humidity and stuff, I thought just go with something that I know won't. And there you go. I'm very pleased with that. Very exciting. And that just sits and will rotate, and I've checked the distances and everything to make sure that it can't set off two at a time, so I hope so. That's lovely. Now to get it all wired up. What's he cutting now, Jim? Well, obviously I need a way to mount that onto this unit, so after much umming and ahhing, I realised he could sit beautifully there. Doesn't get in the way of anything, because obviously this thing has to sweep round. Found a little bit of aluminium that was just right. And what I'm doing now is I've made these things, so I'm going to fix two really long M4 screws, such as this one, here and here, to support it all. And that's lovely. I really didn't know how I was going to do that. That's great, because where this sits on the radio, 1950s radio cabinet, there's the sort of all the fascia with all the controls to the radio on that obviously Ben is going to remove. So this should sit beautifully there, and then I can wire. Oh, it doesn't get much better than this. And I hear you cry, why didn't you print something clever on the 3D printer? Well, I've had an order for another 10 servo-controlled gauge kits, motorised gauge kits, for someone who regularly buys them to make a naughty nice thing, which is very exciting. So as each one takes 5.5 hours to print, here's 8 I prepared earlier, and the fact that the 3D printer is so slow but beautiful, don't get me wrong, time is not an issue, but I'm making them out of wood, and I've just made them in about 4-5 seconds. Obviously, being very impatient, I've stuck those bits together with super glue, but in order to get all these 4 positioned perfectly, there is no way on God's green earth that I'm going to use dimensions. I'm going to fix that on, and I'm going to use PVA. I've got these two correct, having re-drilled them twice. Measure once, drill several times. Anyway, I'm going to use PVA for those, so I can just slide them around. So this is what I'm talking about. I'll fix those on, I'll put glue on in a minute, and then I can line them up with those two. I can't see what I'm doing. There. Oh look, dear friends, that's rigid, which is lovely and really nicely supported, and vertical and horizontal and all the rest of it. Right, I'll get that glued on. It's another day, and I've got a ground connection to each of those, and also to there, because Ben wants it so that when the two key switches are vertical, set by two kids, then it'll play the sound effect over. So I've linked that through to there. So that's all ready to go. Now before I start putting copious amounts of pretty coloured wires on there, before I do that, I need to sort out, that's it, the operation of this switch. Now I've got a magnet going around the back because I could use another reed switch up here. I'm going to have a think about it because obviously I don't want to risk it being switched on by the other magnet that's going round. Alternatively, I could use a micro switch, of which I have a small one here. I don't like to beat my own trumpet, but I'm very pleased with this. Look, there's the micro switch, and I've added, I don't know whether you can see, it's all gone a bit dark, but a spring, a bit of steel spring there, in fact spring steel, and as you turn it, oh look, that's the great thing about adding a spring to the mix, because it switches there, and then you can push it a bit more, and it doesn't harm or damage anything, because the lever is stopped and controlled by the cutout there. So, ooh, that's nice. I like spinny things, but I also like clicky things, actually. Springy clicky things. Ooh. I know what I'm going to do. I'm going to do some wiring, because I think all the switches are now sorted out. And it always is a joy when you have everything arranged with nice little wires poking through things. Isn't it nice? They just poke through that dinky little hole. So that's all that. And it's also really nice when, as I mentioned yesterday, I think, you've got all the thing you can connect everything to, nicely positioned, easily accessible to all the bits and pieces. And I discovered yesterday these aren't memory chips. What an idiot. They are octal buffers. I haven't quite been able to work out why. Anyway, let's start wiring all this up. Look, wires and wires and wires, pretty colours, because I could. Lovely. And I've managed to find a speaker. What I'm going to do now, some of you may have suggested it would have been a good idea before I'd actually wired all this up to see where it does actually work, is I'm going to read through the microscopic instructions again, try and set up the dip switches, and I'm just going to record. It's got a built-in microphone which is handy, and a phono socket or RCA. I've forgotten they were called phono sockets, but I'm just going to use the microphone for now, and I'm just going to record something for each thing very quickly just to see what it does. Right, I have 12 of your very best Voltaires queued up and ready to go into it all. I've tidied the table, I've stroked the dog, I've read the instructions, I've tidied up a bit more stuff, I'm putting it all off, but anywho, I have read them somewhere or other, and I've set the dip switches to what I'm required to do, I think, and I've got the record instructions. I'm just going to have to do it, aren't I? I'll put this on a tripod so you can watch my chaos unfold. I've got my record button ready. I think number 2, which is that, is the 540 million years mid-Cambrian. I'm going to switch the power on, see if any blue smoke comes out. I've just got there, check. Oh, ooh, we've got a green light. Now I believe that you press red light for record. It's nice they've used nice big LEDs as well. So I think I have to touch that onto the thing and then speak and then stop. What am I saying then? Oh, it's nerve-wracking, I tell you. Mid-Cambrian, 540 million years. Mid-Cambrian, 540 million years. Well, a couple of things come to mind. One is that this voltage regulator gets incredibly hot, and out of interest it says it runs on 12 volts, needs 12 volts. It's a 7805, so that's turning 12 volts without a heatsink into 5 volts, which is ridiculous. I've got it running on 7 volts, it's absolutely perfect. I can't drop it too low, otherwise the voltage regulator will drop out. Second thing, on one side of the microscopic instruction sheet, it is in English, and there's the bit that tells you to do the dip switches to set how many recordings and things. And if you look very carefully, I've got a helper that's just turned up. Oh, bless her. She's good at binary. Yeah. This is switch 6, switch 5, switch 4, switch 3. Quite clearly, I can read that. But you turn it over to the Spanish, I think it is, or Italian. Look, switch 3, 4, 5, 6. I wonder why they'd reversed it on the other side. That's a bit odd. So someone has gone to the trouble of mucking about with the graphics and things deliberately to screw it up. So now some of it works, but some of it doesn't. So I'm going to have to. It was only a trial, a test anyway. I'm going to go through it again. Now I've got it set properly because I discovered that. Because after 15, it wouldn't actually record any more. Why 15? I don't know, but it seems to work now. That is so naughty that someone's deliberately gone to the trouble of mucking about with the graphics and swapping the numbers all around. That's really ridiculous. I think I will let the company know. Continuity? Nah, mate. Thanks very much for watching. I thought I would just let you know the reason for delays, not many videos recently, is that if you've been watching the channel for a while, you'll remember in November last year I built a mum monitor because my mum, 95-year-old mum, had a nasty fall and was living downstairs at home. Sadly, she passed away peacefully a couple of weeks ago. I just wish emotions were as easy to deal with as engineering projects. So it's all been a bit up and down recently. Hopefully we'll get back to normal soon. Thanks again for watching. Hope to see you next time.